today we'll see a topic based on dimension analysis. There are so many uses of dimension analysis. We'll see one of the use to check the correctness of an equation. Checking the correctness of an equation is based on a principle known as principle of homogeneity, which says that an equation is said to be dimensionally correct if each term of the equation is having the same dimension. For example, if you take V is equal to U plus AT, which is the first equation of motion. So there are how many terms here? 1, 2, 3. There are 3 terms here. So this equation is said to be dimensionally correct if each term of the equation is having the same dimension. Let us find the dimension of each. First term is what? First term is final velocity. Second term is initial velocity. Then acceleration. Then T stands for time. So velocity, how do we define velocity? Velocity is defined as displacement by time. Displacement by time. What is the displacement dimension? Dimension of displacement is what? Displacement dimension is L. Dimension of time is T. So dimension for velocity is Lt raised to minus 1. This is the dimension for velocity. Next term is what? This is final velocity, this is initial velocity, and A stands for what? Acceleration. Acceleration is defined as what? Acceleration is defined as velocity by time. So what is the dimension for velocity? Dimension for velocity already we know, Lt raised to minus 1. So Lt raised to minus 1 by T. So dimension for acceleration is what? Lt raised to minus 2. So we know the dimension of velocity, we know the dimension of acceleration. Now we can substitute the values here. So when you substitute here, velocity, final velocity is Lt raised to minus 1. So the dimension for the first term is Lt raised to minus 1. Second term should be also what? Lt raised to minus 1. And third one is Lt raised to minus 2 into T. So the dimension of each term is what? Each term is Lt raised to minus 1. So you can call this equation as what? This equation is dimensionally correct. Equation V is equal to U plus AT is what? Dimensionally correct. Let us take another equation now. S is equal to UT plus half AT square. So we'll see the second equation and check whether the equation is dimensionally correct or not. So in the equation S is equal to UT plus half AT square. So this is the equation S is equal to UT plus half AT square. So the first term stands for displacement. Second term we have initial velocity into time. Third term we have a number, acceleration, then square of time. Let us substitute the values of dimension for each term. Displacement dimension is L. Initial velocity is what? Lt raised to minus 1 into T. Then we have a number. There is no dimension for a number. So Lt raised to minus 2 is the dimension for acceleration. Again we have what? Again we have the dimension of T, which is T square. So the equation will be dimensionally correct only if each term, the first term is having dimension L. So all other terms should have the same dimension. So this is L, first term. Second term is also L only. Say third term, these two T square and T raised to minus 2 will cancel each other. So third term is having dimension of L.